So before you can dig deeply into the science of physiology, you have to understand some of the basic rules. And one of the first questions you need to answer is the question, or need to be able to answer, is the question, what are matter and energy? And you might even be asking yourself, well, why should I even care about matter and energy? Well, let's just show you how critical this is. I want you to think about every TV show you've ever seen or movie where there's a classroom and they want to make it clear that it's a science classroom without doing any real science. So if they want to make it clear that it's a science classroom, what's written on the chalkboard somewhere in the room? Right? E equals mc squared. You see that? It's a science classroom. Well, this equation, which comes from Albert Einstein, I don't want to talk about Einstein and what he was doing with it. I just want to talk about what's in it, because that's going to set up what I actually want to talk to you about in the next few videos. So let's break this equation down. E is energy, m is mass, and c is the speed of light, which is a constant. So in essence, this equation is showing us the interconversion, or the relationship between matter and energy. So what are matter? What is matter? What is energy? Let's start with matter. Matter is anything that has mass and takes up space. You can think of it as the physical stuff of the universe. Energy, on the other hand, is the capacity to do work. Work is like every other term in science. It has a precise definition. In physics, work means the movement of matter. So in essence, energy is the capacity to move matter. There are two basic forms of energy. There's kinetic and there's potential. Kinetic energy is energy actually associated with motion. It's matter in motion. It's actually doing work. On the other hand, potential energy is what we think of as positional energy or stored energy. It's energy that's not currently doing work but could be used to do work. So a simple illustration of the difference between these two is to think about this classic example of something like a boulder sitting on the top of a hill. The boulder sitting on the top of the hill is being acted on by gravity. Gravity's pulling downward, but we've got that little block there preventing the boulder from rolling, so that's only potential energy. But if we remove the block and let the boulder roll, that potential energy gets converted into the motion of the boulder rolling down the hill, which is kinetic energy. So the potential to move matter, the movement of matter, and matter. Matter is anything that has mass and takes up space. Energy is the capacity to do work or move matter, and it comes in the forms of kinetic and potential energy. The next thing I want to talk to you about then is why our bodies need matter and energy. And once we've established that, we'll get into some of the ground rules, the laws that govern how matter and energy behave.